This whole structure is renal corpuscle, or this whole structure is renal corpuscle, same thing. Okay? This is the glomerular or Bowman's capsule. This is the glomerulus. Glomerulus is formed by afferent arteriole. It breaks up into capillary network. And this is the parietal layer of the glomerular capsule, this parietal layer, you can see. And the visceral layer is formed by the podocytes. These cells are podocytes. You can see the nucleus of podocytes. You can see the pedicels that interdigitate to form filtration slits. You get that? So between visceral layer and parietal layer, there is a space. This space is called capsular space, where glomerular filtrate accumulates and then passes through the first part is the proximal convoluted tubule, and you can see the microvilli. And these cells are called brush border cells. Yeah? These are brush border cells. You can see this blue line, blue color, marks the microvilli. If you make a section through this is the PCT, proximal convoluted tubule. Okay? And then through, so here, proximal convoluted tubule. Now this is the distal convoluted tubule. Look here how it forms. Blood flow, say, to make the long story short, after some branching out from the renal artery, this becomes interlobar artery. This is arcuate artery. This is interlobular artery or cortical radiate artery. Afferent arteriole. You can see afferent arteriole breaks up into capillaries called glomerulus. Okay? Then afferent arteriole forming peritubular capillaries or vasa recta, and this is the proximal convoluted tubule. When you, this is the first part, when you take a section, it will look like this. Now here is the thin limb. This is the descending limb of loop of Henle. This is the ascending limb. This is the loop of nephron. If you make a section, here the cells are simple squamous cells. Here is a thin loop. You see the thin segment? This is the ascending limb of loop of Henle. If you make a section, it will look like this. Ascending. Okay? Then DCT, this becomes convoluted, distal convoluted tubule. If you make a section, you will have a section like this. This is DCT. This is lumen of DCT. Then the DCT drains into, what is that? Collecting duct. Also called cortical collecting duct. But here is medullary collecting duct. You can see that several DCTs drain into collecting duct. This is a collecting duct. Look at the lumen, diameter of the lumen. Okay? This is the ascending, these are the macula densa cells. Now again, the artist, the one who was preparing who prepared this model, got emotionally carried away and put instead of these cells, look here, these are the JG cells, juxtaglomerular cells of the afferent arteriole. It's not hipped like outside, but when you go to the key of this model, these are labeled as juxtaglomerular cells. But you know, the juxtaglomerular cells are located inside the afferent arteriole. These are the juxtaglomerular cells. These are the baroreceptors. And this is the ascending limb of loop of Henle. And these cells, adjacent to JG cells, These are the macula densa cells. So here you have several specialized cells, and they have special functions. Like these are the cells of the parietal layer, the cells of visceral layer called podocytes, the cells in the apparent arteriole, these cells are called G cells, and the cells on the ascending loop of Henle, these are called macula densa cells. Macula densa cells and JG cells form the JG apparatus. You get that?
Mm-hmm.
This is the efferent arteriole formed by the glomerulus. Okay? Now you're ready for this.
Oh, okay.